All right, in this lesson, we are going to add and subtract polynomials. So by the end of the lesson, you should be able to do these two problems. So first of all, what is a polynomial? So there are different types of polynomials, and they are named based on the number of terms is in the polynomial. So in our class, we're going to focus on four main types. We're going to talk about a monomial, a binomial, a trinomial, and a polynomial. So a monomial, mono, if you've heard that term before, so monotheistic means there's one God. So a monomial has one term. A binomial, if you've heard of a word like bicycle, means there's two terms. A tricycle has three wheels, so a trinomial has three terms. And then a polynomial is actually any of those. But we generally refer to, if it has two terms, we call it a binomial. If it has three terms, we call it a trinomial. So we usually say a polynomial for something that has 4+ terms. Polynomials are usually written in standard form, which means that the terms are placed in descending order from the greatest to the least degree. And degree is just the largest exponent value. So for instance, when I look at this first example, I see that it has 4 terms because a term is divided by a plus or minus sign. So 5x is a term, positive 2x squared is a term, negative 1 is a term, and positive 3x to the 4th is a term. So to put it in standard form, I'm going to take the terms and put them in descending order from greatest degree to least degree. So again, we said degree is that exponent value. So here I have x to the 4th, I have x to the 2nd, and when there isn't a number there, it's x to the 1st because there's one x. And then this is called my constant, which means it doesn't have an x. It's always going to be negative 1 no matter what x value is. So I'm going to write those terms in order from largest to smallest degree value. So my positive 3x to the 4th is going to come first, and then my positive 2x squared is going to come next, and then my positive 5x is going to come, and then the last one is negative 1 is going to be on the end. So if I have any constants or numbers without variables, they will always come on the end. All right, go ahead and pause the video and write example 2 and example 3 in standard form. All right, so hopefully you were able to see that the negative 3x squared is the largest degree, so it's going to come first. And then the positive 10x will come next, and then the plus 11 is on the end. And then down here, we always keep the sign that's in front of the term. So minus x to the 3rd is the same as negative x to the 3rd. Positive 15x is the same as plus 15x, and then my plus 3 on the end. All right, so I'd like you to classify the polynomial by its terms. So am I going to call it a monomial, a binomial, a trinomial, or a polynomial? All right, so the first one is a trinomial because it has 3 terms. The second one is a binomial. It has 2 terms. And then this one, hopefully you were not tricked, but it's actually just one long term because it's all multiplication. Remember, a term is divided by a positive or a negative sign, a plus or a minus sign. And then this is a polynomial because it has more than 3 terms, so it's 4 or more terms. All right, so I'd like you to take these examples, and you have them on your paper. Go ahead and rewrite them in standard form and classify them by the number of terms. All right, so some of these were a little tricky, but let's see how you did. First of all, check and see that you named it by the number of terms correctly. So the first one is a monomial, a binomial, a monomial, a trinomial, a monomial, a polynomial, and a binomial. So in standard form, hopefully you noticed some of them were already in standard form. So I hope I wasn't able to trick you. So if it's a monomial, it's already in standard form. There's no rewriting at all. So this binomial is 5x plus 9. This one was already in standard form, 8x to the 4th minus 2x to the 3rd plus 3x. This was also already in standard form. Now this one down here got a little tricky, so 8x to the 4th positive came first, minus 2x to the 3rd came next, plus 12x squared came next, minus 3x, and then lastly I have plus 1. And then this one, I threw in some extra variables, but we always go by the first variable alphabetically. So I have a's and b's, so I'm going to put it in order by a's because it comes first alphabetically. So 2a to the third b is going to come before 4a to the b, or 4ab to the third, because this a is to the power of 1. All right, so one area that students tend to struggle or get confused is the difference between x plus x and x times x. So x plus x, I'd like you to go ahead and do that right now. So x plus x is 2x. If I have an x and I add another x, I have 2 x's. So when I combine like terms, I'm not sure why I did that. When I combine like terms, my answer doesn't change the exponent. Like terms, so if I took apples and added more apples, they don't turn into oranges. So x plus x doesn't become 2x squared. It stays what it is. Whereas over here, when I'm multiplying, this is x to the first times x to the first. And so x to the first times x to the first is x to the second. So when I'm multiplying the bases, that I add the exponents. And that's just something we're going to do a lot of practice with. But I need you to keep it clear when I'm adding x plus x is 2x, x times x is x squared. We'll do more practice with that. So 2x plus 3x is 5x because I'm combining like terms. And 2x times 3x, I'm going to multiply. And then x to the first times x to the first is x to the second. So adding, combine my like terms, multiplying, I multiply my coefficients, and I add the exponents. All right, so 4x squared plus 3x. That is going to be 4x squared plus 3x because they are not like terms. X squared is different than x, so I can't combine them. But 4x squared times 3x, I multiply my coefficients, and I have 2 x's here and 1 here. So x to the second times x is x to the third. All right, go ahead and try this one on your own. All right, so over here, I'm combining like terms because I'm adding. So 5x squared plus x squared, that is like 5x squared plus 1x squared gives me 6x squared. But 5x squared times x squared is going to be 5 times 1, which is 5, and x squared times x squared is x to the fourth. So here are some guiding questions that will help you think through these adding and subtracting polynomials. So first of all, what operation is occurring? Second of all, do I need to clear any grouping symbols? Third, what are my like terms? And then fourth, is my answer in standard form? All right, so the first question I'm going to ask myself is, what operation is occurring? So when I look at this, I see that addition is happening. So I'm just combining like terms by adding those two parentheses together. So do I need to clear any grouping symbols? Well, I have some parentheses. So the first grouping symbol is just saying this value, so that's not going to change. G minus 4g squared plus 11. And I'm adding negative g squared, so I'm subtracting, because plus and minus means subtracting, and then I'm adding a positive g squared, 8g, so it's just 8g. So if you notice, when I'm adding this second one, the signs don't change, because I'm just combining those. So my third question is, what are my like terms? So I have a negative 4g squared and a negative g squared because I want to put it in standard form, so I'm just going to go ahead and start putting my largest exponent together. So negative 4 minus 1 is negative 5g squared, and then I have a g and an 8g, so 1g plus 8g is a positive 9g, and then I have this plus 11 that doesn't get added with anything, and so that's my answer. So go ahead and write down any questions that you have, or any things that you think, oh, I need to remember to do this. So have an interaction right now. All right, I'd like you to try this problem on your own. All right, I got negative 13k squared plus 12. So I want to think about those questions. So what operation is occurring? Well, it's addition. Do I need to clear any grouping symbols? Well, I have two parentheses, so I have to make those parentheses no longer relevant. So this has nothing outside of it, so those parentheses don't need to be there. And then I'm basically adding 7 and adding a negative 16k squared, which is just minus 16k squared. So then what are my like terms? I have a 3k squared minus 16k squared, so I have 13k squared. So remember, when I'm combining my like terms, the exponent doesn't change. So if they're k squareds up here and k squareds here, they're k squareds here because I'm just combining them. And then 5 plus 7 is 12. All right, so this example, what operation is occurring? Well, this time it's going to be subtraction, so we got to pay attention to that. Do I need to clear any grouping symbols? Yes, I have some grouping symbols. So the minus 12h to the 4th plus h just comes down because there's nothing outside of the grouping symbol that needs to be distributed. But now I'm subtracting a negative 6h to the 4th. So if I subtract a negative, it actually becomes a positive. And then I'm subtracting 3h to the 2nd. So subtracting a positive is a negative. And then I'm subtracting a negative 4h, so a negative 4h becomes a positive 4h when I subtract it. So if you notice, nothing changed in the first parenthesis, but when I subtract, all of my signs did the opposite because I'm doing the opposite. That's what subtraction is the opposite. So now, what are my like terms? So I'm going to find my largest degree, which is h to the 4th. So negative 12h to the 4th plus 6h to the 4th is a negative, not 8, negative 6 h to the 4th. And then I have 1 negative 3h to the 2nd. I don't have any other h to the 2nds. I just have that 1. And then I've got a plus h and a plus 4h. So 1h plus 4h is 5h. And that's my answer. So go ahead and have an interaction with this problem. What questions do you have? Where are you confused? What things do you need to remember? So most of you are going to want to write down, be sure to distribute that negative because that changes everything. All right, go ahead and try this example on your own. All right, I got 3a squared minus a plus 10. And so I distributed that negative, so my signs changed. The 2a became negative, and the negative 5 became positive. And so I brought my 3a squared down because it's the largest degree. And then 1a minus 2a is negative 1a, and 5 plus 5 is 10. All right, I'd like you to try the remaining, or the next 4 problems and see how you do. All right, so for this example, you should have gotten 47e cubed plus 4e squared. If you didn't get that, look back at my work, and if you still don't understand it, make sure you have an interaction so we can talk about it when you come back. All right, so for this example, you should have gotten minus 15d cubed, or negative 15d cubed, plus 3d squared, plus 3d, plus 4. So for this example, you should have negative 8x to the 3rd minus 4x squared, plus 8x minus 4. And for this one, 8p cubed plus 11p squared minus 11p minus 11. And this one, negative 4s cubed minus 2s squared plus 3s plus 4. All right, so this one we're going to take this rectangle where we know the length is x minus 2 and the width is 2x plus 3. And our job is to find the perimeter of the rectangle. So the perimeter is the distance around. So if I know that this length is x minus 2, then I also know that this length is x minus 2 because those lines are the same length. And if this is 2x plus 3, then this is also 2x plus 3. And to find the perimeter, I know that we add all the sides. So I'm going to add this side plus, I'm going to add this side plus this side plus this side. And so I'm adding them all together. So when I'm adding, the signs don't really have any impact. So it's going to be x minus 2 plus 2x plus 3 plus x minus 2 plus 2x plus 3. So it would be like if I distribute those positives. And so now I combine my like terms. So x plus 2x is 3x, plus x is 4x, plus 2x is 6x. So combining my like terms, I have 6 x's. And then negative 2 plus 3 is a positive 1. Minus 2 is negative 1. Plus 3 is a positive 2. So the perimeter is 6x plus 2 units. That would be the distance all the way around. So if you have any questions about that, make sure you write those down. What are things that you would need to remember about this? What are your be sure to statements? What makes sense? Have an interaction in your notes. All right, I'd like you to try this problem on your own. It's asking you to find the perimeter of the rectangle, so it's similar to the previous problem. So hopefully you were able to get 12x to the third plus 10x minus 10 units long is going to be the perimeter. So go ahead and look over my work. If you have any questions, write those down and we can talk about them when you come back. So what are 3 mistakes you think that students make when they add or subtract polynomials? So where do you think those errors tend to happen? So look back at your work, think about things that you might have done wrong when you were trying it, and then what do you need to remember about adding and subtracting polynomials? This is your be sure to statements that go in that reflection box on your notes.